Polymerization. Here we have a polymer and monomer. Monomer means 1 units. So mono, 1 units. Here is a monomer right here, ethylene. Polymer means many units. So basically we're going to multiply the number of monomer units. So N could mean 1 kajillion. It could mean a Google, which is a thousandplex. It could mean Avogadro's number. So I'll just say a really large number. I'll pick 10. And what happens is when we add in these environment, heat, pressure, and a catalyst, these will basically link together like links in a chain link. So here are the links over here for the monomers, and then here is an abbreviated linked chain. This is a linked chain over here. A linked chain. Okay. Here is a here are the ethylene molecules themselves. Here's a much better picture. And this shows, whoa, it shows 3 molecules. And what's going to happen is, as these pi bonds, instead of grabbing diatomic molecules, they're basically going to cannibalize each other, or So this is an R-rated video. So here they're going to cannibalize each other. And they're going to bond to each other. So there's going to be a lot of inbreeding, and when they link together like a nice grotesque linked chain, it forms a polymer. So ethylene molecules that are linked together, many ethylene molecules linked together, form a polyethylene. Clever how we came up with these names, huh? Cool. Ethylene is a common name. Usually we would say 1-ethene if we use UPAC, but ethylene is the common name. So they just went with it. And when you write a polymer of ethylene molecules, it's polyethylene. You'll be responsible for knowing the concept of polymerization, monomer to polymers, but I'm not going to ask you to write any actual or predict any actual polymer. So recognize the examples only. Know the 5 types of reactions, predict and name the first 4 reactions, and you're not tested on the mechanisms at all. In the future, to give you a point of reference, I may refer to the mechanism just to, if you're curious about all the nuts and bolts, to help you understand it, but you're not tested on the mechanisms. Let's go ahead and do some really quick problems, so that way I have even more stuff for you to download and for you to wait forever for this to be, whoops, that was one of the answers. You didn't see that, and you didn't see this either, you didn't see this either. Good times. Alright, let's go to this. You can see this over here. Note to self, delete those slides. Woo, okay, where are we? Yeah, we'll go here. Let me go ahead and download these alkane reactions. Here we see an example of the hydrogen gas molecule, hydrogenation, and it's going to bond, and here it forms a new structure along with butane. Please note that this program cannot make expanded structures properly. You have to play with it like you saw me at the very beginning of this little speech. So it's great for making condensed and line angle structure, so you'll probably see a lot of those on the future exam. So let's go down to this problem right down here. In this case, I'm going to go ahead and add in chlorine gas molecule. Let me go ahead and create my structure. So in this case, notice it's a homodiatomic molecule. So Markovnikov's rule is kind of irrelevant. So now I need to go ahead and add in my chlorine. I'll go ahead and do that right now. This may take me a second because, again, it's not designed for it. So I add in the methyl group, change it to a chlorine, and voila. I made it. This should help you out, especially when you're making these to turn them in for your questions. So now we have our structure. Now I go ahead and hit the UPAC name, and voila, 1,2-dichlorobutane. You'll be expected to sketch it as well as name it on upcoming material. So in this example on the next one, I could really try to play with your head and change this to a, how shall I change it to? I'll probably change it to a fluorine. Ooh, scary. Alright, so now we have fluorine, and then I'm going to go ahead and copy this. And I'll change it to, guess what, a fluorine. So you should know how to name this one. This next one's going to be a harder one. So let me go ahead and erase that. This one right here, keep in mind, heterodiatomic, and you'll notice that one side has more hydrogens than the other. So we need to apply Markovnikov's rule, the rich get richer. The rich get richer. So on the right-hand side, there's more hydrogens than on the left-hand side. What you might have to do is make a temporary intermediate expanded molecule just so you can visually reference out where all the hydrogens are. That's what I highly recommend. Don't try to do it all in your head. Otherwise, you may make a mistake like me with all my umpteen typos. So in this case, I'm going to go ahead and create a brand new structure. So 1, 2, 3, 4. I'm then going to go ahead and which one has the hydrogen? Turns out it's going to be the N carbon over here that's going to have the hydrogen. I'm going to go ahead and change it and turn this into a hydrogen. That's a nitrogen. Oops. That's a nitrogen with way too many bonds on it. That's a nitrogen that doesn't want to lose its bond. Alright, let's go ahead and change this before. Uh-oh. See, I totally understand how you feel. Alright, so I'm going to go back to here. And then change. Come on. Change this to a hydrogen. Yes. And then I need to go ahead and add in a carbon here. I know this takes a long time. So let's go ahead and add in a chlorine. And then voila. Oops, no wonder. This is in front of it, and I'll just move this to the side. There we go. So the rich get richer rule. Here we have one last problem. Down here, again, this can be really tricky, so my advice is to go ahead and turn it into a condensed or expanded structure. And you can always use the program to help you out. Just keep in mind that every time you do it, you may lose your halogens or any other derivative on there, so you may have to start over again. So I want to go ahead and delete this. That way I can make a lot of extra space so I can count the number of hydrogens. Voila! We are on. I can't see anything because the font is so big, so let me make the font smaller. I can't see you either. There we go. Oh, that's weird. Can everybody see that bug right there? I don't know why. Oh, that's because it's not even attached. Alright, let's attach it. If I bring it close, boom, it just attached. There we go. Alright, now, this one has one hydrogen, this has no hydrogen. The rich get richer. So in this case, I'll go ahead and I'll copy it, then paste it, drag it over here. And then I'm going to go ahead and click on that. Need to change the number of bonds. There we go. So I went ahead and I added in an extra hydrogen, and then I need to go ahead and add in a alkyl group over here. So in this case, I'm going to go ahead and click on this one, change it immediately as soon as I add in the methyl group. Alright, so I added in a methyl group again, and I need to change it to a chlorine. Carbon chlorine. Okay. Now, there's our final structure right here. Keep in mind I can write it like this, or I could sit there and I could expand out that hydrogen. It's probably a little bit easier to expand out the hydrogen on a piece of paper. On this program it's a little bit harder, so if you were to write it like this, I'd still give you full credit. You can have the chlorine down here, you can have the chlorine on top, doesn't matter, you will still get full credit. Let's go over to this side over here to the left. To the left. To the left. What I'm going to do differently is I'm going to change this to a alcohol. I'm sorry, a water. I'll change it to a water. OH. Capital OH. Same thing, the Markovnikov rule was obeyed. This carbon right here, which I'm highlighting with my cursor, this received the hydrogen, and the other carbon received the hydroxide. I just need to go to my product, and I'm going to edit the molecule, and I'm going to change it and add in a oxygen. Keep in mind, technically, you should always show the hydrogen on oxygen. Always, always, always. That's how it's always done for alcohols. So I can right-click on this oxygen, and I'm going to show the hydrogens. Voila. Then I have my nice structure right here. I'm curious what the name's going to be. My guess is it's going to either be 3-hydroxy, 3-methyl pentane, or it will be 3-methyl pentanol. Aha! 3-methyl pentan 3-ol. It turns out there's more than one way to write alcohol as a UPAC name. You can either write it as a prefix or a suffix, and I'll give you that explanation when we get into the 3-4 handouts. And keep in mind that whenever you do any changes, sometimes it undoes the work you put on the molecule, so make sure to readjust it again. This concludes our Chapter 1-2, Part 3 video documentary.